Right guys, let's have a go at question 6 then. It's y equals x plus 1 over x. Again, we can write that on ground level if we want. So let's just do it now. X plus x to the minus 1. Bring the x up to ground level, flip the index, yeah, from 1 to a minus 1. Great. Now let's just differentiate, get the gradient function then, see what that is. X goes to 1. The minus and the plus combine to be a minus. X to 1 less than minus 1, which is minus 2. Let that equal 0. Okay, so what we can do is, we could write that as minus 1 over x squared, couldn't we? That's more convenient to move things around with, isn't it, in that form? So we've got that thing there, we've just written it here, we'll let it equal 0. Now I'm going to move that across the equals. So that would give 1 equals 1 over x squared. Now we're going to move this from divide up to times on the other side. So just divide on one side, up to times on the other side. So I can write x squared equals 1 then, can't we? Square root both sides, remember the rule for indices, x to the power, u times ab, there's the rule. So to undo a square, we'll need a half, that's a 2, so you'll need a half to get a product of 1, wouldn't you? 2 times a half is 1. So to undo a square, you have to do power half or square root to get power 1. If it were a cube, you'd have to do a third. That would be a 3 and that would be a third. 3 times a third is 1. So to undo a cube, you cube root. To undo a fourth power, you take the fourth root. Okay, so to undo a square, as we said, you square root. So square root both sides, x on the left, as we said, x to the power 1 is x, and the square root of 1 is 1, but a plus or minus pops up, doesn't it, for the square roots. So we've got our two turning points here. So at x equals 1 then, there's the first one. What does y equal? Well, let's look back, put 1 in here in your mind's eye, put 1 in there, 1 plus 1 over 1, that's 1, 1 plus 1 is 2. There we go, the other input is at x equals minus 1. Let's put that in then, in our mind's eye. Minus 1 here. 1 over minus 1 is minus 1. Put that thing there. So you've got minus 1, take 1 is minus 2, haven't you? So y equals, I'm going to write it out long-windedly, just to be absolutely happy. Everyone on board. Yeah, that makes a minus 1. Minus 1, take another 1 is minus 2. Okay, so there's our turning points then. At 1, it's 2. And at minus 1, it's minus 2. Okay, great. So now we need the second derivative, d2y by dx squared then. Let's get that while we're at it. Differentiate, which is easiest? This thing here, isn't it? To differentiate by dx. Let's use this form. That goes to nothing. Minus comes down to be with the other minus to make a plus. 2, x to the 1 less than minus 2. Yeah, 1 less than that is minus 3. And you can write that as 2 over x cubed, can't you, if we drop the x to minus 3 down below ground level. So, what does that equal then? When x is 1. Well, if you put 1 in here, 1 cubed is positive, 2 over a positive number is positive, so that's positive. And that's all we need to worry about. So that's a min. And if we put minus 1 in as the input, yeah, minus 1 cubed is negative. Positive over negative is negative. So that's all we need to worry about. And that's a max then, isn't it? Quite clearly. So we know all the information then. Let's draw the graph, shall we? Of x plus 1 over x. So we've got y equals x plus 1 over x. We're going to draw our axes. Now the turning points were at 1 and minus 1, weren't they? When we put 1 in, we got a value 2. Remember? Output 2. So there's the turning point. We don't know what form it has. And when x was minus 1, it was minus 2, if you remember. And there's the turning point there illustrated. So let's look back. 1 it was 2, at minus 1 it was minus 2, yeah? And we said about the max and mins, didn't we? Let's just have a quick look. At 1 it was a min, at minus 1 it was a max. So at 1 it was a min, so we got that. And minus 1 it's a max, so we got that. Okay? So that's what we've got then. Good. Now, what on earth happens here? Because it cannot turn in between any other two values, can it? No, it can't turn at all. Right? So what's going to happen here then? Right? It's not going to swing back up here and join up to there because it would be another turning point. So something's got unusual's got to happen here, hasn't it? So here's our y-axis. Better put that in. Here's our x-axis. Here's 0. Okay. So let's have a look at this curve then, because we're doing a tiny bit of curve sketching as well, aren't we? So when x is large, say put in 10. Yeah, you'll get 10 plus 1 over 10, which is a tenth. just a smidge, 1/10, 0.1, 10.1. So it's just so basically what I'm trying to say, if x was 100, this would be 1 over 100, wouldn't it? Be 100 plus 1 over 100, just above 100, 100.01. So what I'm trying to say is that for large x, this value gets really, really small and positive. And it just sits above this line here, the line y equals x. So let's put the line y equals x in then, in the sketch, as dash, because it's going to tend towards that for large positive values. Let's put it down for, just in case it tends for large negative, which we'll have a look at that in a moment. Alright, so for large positive, we said like 100, it'd be y equals 100 plus 1 over 100, so it'd be here. And I know I'm not doing it to scale, but had it been 1,000, you'd get 1 over 1,000 plus 1,000. So it'd be a tiny bit above that line, wouldn't it? I know that's not to scale. But what I'm trying to illustrate is that as x gets larger and larger and larger, it gets closer and closer to that line, the line y equals x, but just a tiny bit above it. Now if we look on the negative side, say minus 100, you'll get minus 100, say, plus 1 over minus 100, wouldn't you? That is plus over minus is a minus. 0.01, it's really, really small. You got minus 100 less a really, really small number. So it's just underneath that value. So what I'm trying to say is it's here. And then the bigger x negative you get, the closer it will get to the line. Like for example, minus 1,000. See how small that is? That's 0.001 with a minus. So it's a tiny fraction, or tiny decimal, below the minus 1,000, which is the value of here, this line here. Yeah, so this dominates. For large x, positive or negative, this thing predominates, so it tends towards that value. On this positive side, it's just above. On this negative side, it's just below. So that's that problem taken care of. Now what about either side of 0? Because something peculiar must happen here, because it cannot turn here and here, can't it? So let's have a look at close to 0, because that's when this is not defined. Because you can't divide by 0, can you? So say 0.1. So let's have a quick look at 0.1. Let's see what we get there, shall we? So if you put 0.1 in, you're going to get 0.1 here, plus 1 over 0.1, aren't you? 1 over 0.1 is 10. This is going to be 10.1. So at 0.1, it shoots up to 10. If we do 0.01, yeah, what's that going to look like? Because we're getting closer to 0 now. That would be 100.01. So can you see as we get x tends to 0, this term gets very, very large. So it shoots up here, doesn't it? It gets bigger and bigger and bigger the smaller x gets. And then on the negative side, if you did minus 0.01 and minus as inputs, this would be minus 100, wouldn't it? Which is very large negative and a smidge below that. So what I'm trying to say is on this side it just goes down like that and shoots down there negative. So can you see what's happening? We can actually draw it now, can't we? So let's draw it. I'm just gonna count. So it's gonna shoot down here. So what's gonna happen to the curve then? Well, it's gonna come up, turn to a maximum and tend toward that line. And then it's gonna come off this line, tend to its minimum, shoot back up and shoot back up there. There we are. That is the line y equals x plus 1 over x. So let's just confirm that with a sketch then. So I think I've already tapped it in to a little calculator that you can get. There's plenty of them on Google. And I typed it in earlier on, x plus 1 over x, just to have a little look at it. And you can take various. I've done mine as 10 to 10. Yeah, tap that out. X, see it there? X plus 1 over x there. If you enter that, you get this graph like we said. There it is. So you can pick these up, not to a penny, but there's quite a few of them on Google. Just type in graphing calculator or graph plotter or something into Google, pick one up, and you can check all your graphs are correct. Alright then, so that's that one done. Question 6, let's go on to the next one. Great.